Removing the handle tie from a tandem breaker in a mobile home, where the 20 amps outside breakers connected by a handle tie were feeding two separate 120-volt circuits that are not multi-wire, was not the correct action. Tandem breakers are designed to provide two independent 120-volt circuits from a single 240-volt panel. These breakers have a handle tie that prevents one breaker from tripping without the other. This is necessary to ensure that both circuits are always energized and to prevent overloading. By removing the handle tie, a potentially dangerous situation has been created. If one circuit trips, the other will still be energized, which could lead to an electrical fire. The handle tie should be reinstalled, and the tandem breaker should be left in place. If there are concerns about the possibility of one circuit tripping and causing the other to trip, installing a separate 20 amps breaker for each circuit would be the correct approach. A tandem breaker, also known as a double stuff breaker or a half-size breaker, is a type of circuit breaker designed to allow two circuits to be installed in a single breaker space within an electrical panel. These breakers are commonly used to maximize the number of circuits in a panel that has limited space. Understanding their function and proper application is crucial for electrical safety. Firstly, the primary function of a tandem breaker is to provide two independent circuits in a single breaker slot. This is achieved by having two separate switching mechanisms within one breaker body. Each mechanism protects a different circuit, allowing for two 120-volt circuits to be installed where only one standard breaker would normally fit. Secondly, handle ties or handle locks are used to mechanically connect the handles of two adjacent single-pole breakers, causing them to trip simultaneously. This is essential for circuits that supply 240 volts loads, such as electric dryers, water heaters, or some air conditioning unit. The handle tie ensures that both poles of the circuit are disconnected at the same time, preventing potential hazards. Thirdly, in the situation described, the tandem breaker was being used to feed two separate 120-volt circuits, and the removal of the handle tie was intended to allow each circuit to trip independently. However, this action is not advisable because the original design of the tandem breaker with the handle tie serves a specific purpose, which is to maintain circuit integrity and prevent overloading. When a handle tie is removed from a tandem breaker that is intended to supply two independent 120-volt circuits from a 240-volt panel, several potential issues can arise. 1. If one of the circuits experiences a fault, such as a short circuit or an overload, only that side of the breaker will trip. The other circuit will continue to operate, potentially leading to an imbalance in the electrical load within the panel. 2. An imbalance can cause excessive current to flow through the neutral conductor, which can overheat and create a fire hazard. 3. The continuous operation of one circuit while the other is faulted can also make troubleshooting more difficult, as the problem may not be immediately apparent. Reinstalling the handle tie is important because it restores the intended functionality of the tandem breaker. With the handle tie in place, if either circuit experiences a fault, both circuits will trip simultaneously, ensuring that the entire load is disconnected. This provides a safer and more reliable electrical system. Moreover, if the concern is about one circuit tripping and causing the other to trip unnecessarily, there are alternative solutions that can be implemented. 1. The most straightforward solution is to replace the tandem breaker with two separate single-pole breakers, one for each circuit. This configuration allows each circuit to operate independently without affecting the other. 2. If space is a constraint, consider using a different type of breaker that is specifically designed for independent operation, such as a dual-function breaker that provides both overcurrent and arc fault protection for each circuit. 3. It is also important to ensure that the electrical panel and the circuits are properly loaded. Overloading occurs when too many devices are connected to a single circuit, causing it to draw more current than it is designed to handle. This can lead to breaker tripping, overheating, and potentially fires. To prevent overloading, it is essential to distribute the electrical load evenly across multiple circuits. This can be achieved by carefully planning the placement of electrical devices and appliances and ensuring that each circuit is not loaded beyond its maximum capacity. Furthermore, regular maintenance and inspection of the electrical system are crucial for ensuring its safety and reliability. This includes checking the breakers for any signs of damage or wear, testing the operation of ground fault circuit interrupters, and verifying that all electrical connections are tight and secure. Any issues that are identified should be addressed promptly by a qualified electrician. In summary, removing the handle tie from a tandem breaker that is designed to provide two independent 120-volt circuits from a 240-volt panel is not the right approach. It can create a potentially dangerous situation by allowing one circuit to continue operating while the other is faulted. The handle tie should be reinstalled to ensure that both circuits trip simultaneously in the event of a fault. If there are concerns about one circuit tripping and causing the other to trip, alternative solutions such as using separate breakers or dual-function breakers should be considered. Proper load distribution and regular maintenance are also essential for maintaining a safe and reliable electrical system. When working with electrical systems, it is always recommended to consult with a qualified electrician to ensure that all work is performed in accordance with applicable codes and standards. Electricians have the knowledge and experience to properly assess the electrical system and recommend the most appropriate solutions for any issues that may arise. They can also ensure that all work is performed safely and in compliance with local regulations. Furthermore, understanding the NEC, or National Electrical Code, is crucial for ensuring electrical safety. The NEC provides comprehensive guidelines for the safe installation and maintenance of electrical systems. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is essential for preventing electrical hazards and ensuring the safety of people and property. For example, NEC Table 310.15. B16 provides ampacity ratings for conductors based on their size and insulation type. This table is used to determine the appropriate size of conductors for different circuits to ensure that they can safely carry the intended load. Another important aspect of electrical safety is grounding. Grounding is the process of connecting electrical equipment and systems to the earth to provide a low impedance path for fault currents. This helps to protect against electrical shock and prevent damage to equipment. The NEC specifies detailed requirements for grounding systems, including the size and type of grounding conductors, the location of grounding electrodes, and the bonding of metal enclosures. Ground fault circuit interrupters, or GFCIs, are another essential safety device. GFCIs are designed to detect ground faults which occur when current leaks from a circuit to ground. When a ground fault is detected, the GFCI quickly trips the circuit, preventing electrical shock. GFCIs are commonly used in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, or FSIs, are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. Arc faults occur where electricity jumps between two conductors, creating a high-temperature arc. FSIs quickly trip the circuit when an arc fault is detected, preventing the arc from igniting nearby materials. FSIs are required in many areas of the home, including bedrooms, living rooms, and dining rooms. Surge protectors are used to protect electronic equipment from voltage surges, which are sudden increases in voltage that can damage sensitive components. Surge protectors work by diverting excess voltage to ground, preventing it from reaching the equipment. Surge protectors are available in a variety of forms, including power strips, wall-mounted units, and whole-house surge protectors. In addition to these safety devices, it is also important to follow safe work practices when working with electricity. This includes always de-energizing circuits before working on them, using insulated tools, and wearing appropriate personal protective equipment. It is also important to never work on electrical systems when wet or in damp conditions. Furthermore, it is important to educate yourself about electrical safety and to be aware of the potential hazards. This includes understanding the signs of electrical problems, such as flickering lights, warm outlets, and burning smells. It also includes knowing what to do in the event of an electrical emergency, such as a fire or an electrical shock. By following these guidelines and taking appropriate precautions, it is possible to create a safe and reliable electrical system that protects people and property from electrical hazards. Remember, when in doubt, always consult with a qualified electrician.